let's start with who I am and what I do. So I am a software engineer at Zenduty. So at Zenduty, we are trying to reimagine how incident management for fast-paced teams can actually look like, helping companies like Book My Show, Navi, Unacademy, Physicswala, and Upgrad, and Rakuten for minimizing their business impacting downtime. Focus at Zenduty lies on refining our interfaces, user experience, and agility to a point. Sorry, to a point where we could our clients should not face any issue, any friction during incidents or any war room situation. So therefore we offer a level of empathy which is unparalleled in the enterprise application space today. So, and that's where I come in as a developer. So if you want to know more about what Zenduty do and what I do at Zenduty, we can talk about this later. I'll be around. So what I'm going to talk about, we will be going to talk about understanding various security vulnerabilities and risk mitigation strategies. We'll be recognizing the importance of security in software development in general. And also we'll be understanding the security and reliability specific problems and solutions in React Native. So let's start with a question. Is security just a backend concept? Or it's, let's say, more of a general term? And if it's so, why aren't we talking about security in front end as much? We talk about UI libraries, we talk about new technologies coming in, Next.js and everything like that, but we don't talk about security as much. So let's try and understand and answer this question. So being security first while building React Native apps is tedious, is very important as well. So the question here is not why we should secure our applications, but rather how can we afford not to? And also we have to also make sure that what sort of trade-off is happening when we are trying to build more performant and shipping faster software. At the same time, we have to maintain a secure code base. So let's find out how to have an optimal balance between those. So to start with, let's understand how React Native works under the hood. So as you can see, there's a JS thread, there's a bridge, which gives us a functionality of two-way communication between the native transpiled code and JavaScript code that we write. So security vulnerabilities can be anywhere. It can be in our JavaScript code because we are using third-party libraries for building our applications, right? It can also happen at the bridge end because what if some developer in the meta team puts some malicious code or whatever? Anything can happen, right? There are vulnerabilities everywhere. It's an open source product. At the same time, there are platform-specific concerns. Platform-specific concerns can be like related to Android-level vulnerabilities or iOS-based vulnerabilities. So let's talk more about these things. Leaky abstractions. What are these? So basically, why people call React Native a leaky abstraction. So basically, leaky abstraction here means some complexity remains visible or accessible, which is often unintentional, but it can actually lead to unexpected behaviors, bugs, and security vulnerabilities. Taking example of React Native here, we don't know what JavaScript function we use, how it is implemented in native side. So they both follow different approaches, Android and iOS. And a very common example is secure storage or async storage implementation. So let's talk about secure storage. In iOS, what happens is when you store data in keychain, it persists even after reinstallation. But in Android, it actually it removes that data after reinstallation, and there are no automated tools to actually look out or scan for leaky abstraction related issues. And so for that, we also have to understand the importance of native modules and everything, so that our team knows and have that knowledge of functionality which we are implementing on the native side of things. So whenever you are building a native application, React Native application, you should know what iOS and Android specific things are and what happens once your code is transpiled to these native languages. So I hope everyone is aware about OASP, right? So OASP is Open Worldwide Application Security Project. So it gives standards and guidelines. It is not like a simple private organization. It is an open source organization. So a lot of people come and build these standards. So OASP has a mobile application security verification standard. So these are few standards that I have mentioned here from the OASP official website. You can actually scan the QR code and have a look at the official website as well. So I'm not going to talk very deeply about these standards because we don't have that much time. But yeah, you can. These are very self-explanatory. Improper credential usage, inadequate supply chain security, insecure authentication, and stuff like that. So you have to make sure these are very general things that you have to make sure for every application that you ship out. These should be met. So these are basic standards. And towards the right, you can also see a very interesting chart of state of libraries used in a financial fintech application built on React Native. So you can see 37.5% of libraries have known vulnerabilities. 12.5% have 100 plus open issues. 25 are abandoned libraries, and 25% are good libraries. So yeah, so this is the state of a React Native application by a fintech company. So food for thought. So insecure data storage. So these are few safe storage methods and unsafe storage methods in React Native. And let's understand insecure authentication. So this is a table that I've taken from OASP official website. You can scan the QR code or use the link and go and have a read. These are some guidelines that OASP has given for authentication and session management related concerns. So you have to make sure these are also met in while you're building your applications, specifically your authentication systems. So to knock off the talk, this is a quote which says, the knock-on effect of a data breach can be devastating for a company when customers start taking their business and their money elsewhere. That can be a real body blow. So your customers, in the end, we are running a business, right? There's an application and we are running a business. And if your application is not secure, you're not able to instill that confidence in your users, right? To actually use your platform because they are not secure about what sort of data security you have, and is their data secure. You have to also make sure that security also equates to business. So we have to make sure our application is secure, people have trust in our application and our whole platform, so that we can have better business as well. So security is that important. It has multiple phases. So one is business. So let's start and understand proactive measures that we can actually take, and also equated with the React Native nuances and everything. So while preparing for this talk, I came across this thing called RASP, Runtime App Self-Protection. So it is a proactive security technology, which actually runs in real time with your application, and it helps you defend, detect vulnerabilities and malicious code and everything. Sort of, it basically checks the user behavior as well. So you can actually see who is trying to have unauthorized access to your application, what sort of data is being transferred and everything. You can actually have a real time function that is running, which is actually checking your application for security breaches. So it gives real-time monitoring. There are some key features, which is real-time threat detection, behavioral analysis, immediate response to threats, and also protection from zero-day vulnerabilities. And it is very effective against unknown threats because it can actually, it can just create a firewall against your app when someone's trying to, do anything which can actually breach your security. Also, we have to also make sure balancing security and performance. While you are implementing a RASP solution, it is very important to understand that RASP is also a function or a platform or a library that you have implemented. So the code is running somewhere. It is taking some compute. It is taking some memory, right? So we have to make sure we don't compromise our app's performance, our user experience also, just for the sake of security. So we have to always fine tune our RASP implementations as well. So talking about React Native, there's one tool that I came across called FreeRASP, through which you can actually implement RASP in your React Native applications. It can help you detect root or jailbroken devices. It can help you prevent or mitigate reverse engineering attempts, and it can also prevent tampering and repackaging of your application. So they also have, this is by a company called Talsac, and they also have a premium version of this sort. Or you can also opt for some third-party platforms which are giving these service, so that you can implement their libraries or packages or software in your application and have a sort of RASP system implemented in your applications. So let's talk about jailbreak or root detection. I believe everyone have tried tinkering with their Android phones, tablets, or iOS tablets or phones. Tried rooting them and everything, jailbreak. right? Or maybe PlayStations and everything. You can actually jailbreak any device. If there's a software, if there's a firmware, you can actually jailbreak it. So breaking a device is basically trying to get root level access of that particular device, so that you can actually tinker with the firmware. You can tinker with multiple applications. You can actually inject some code in an application while it is running. So as a jailbroken device, the user gets access to the entire file system. You can actually install the app of your choice, which is also prohibited by Play Store or App Store. You can actually execute custom programs because you have root level access, and you can also intercept and manipulate data. So there's a library called JailMonkey, which is quite famous. You can actually implement this to detect jailbroken devices. And let's talk about how you can actually, what you can actually do once you detect jailbroken devices while the app is running. So let's say, coming to JailMonkey again. So these are few APIs that JailMonkey gives us. You can actually check if the device is using a mock location, or if the device is jailbroken. And you also have a violation check called Trustfall. And you also have native APIs available for Android and iOS, which are different. So I did not want to talk about that here, but you can actually refer to the documentation and have a look. So what if your app detected jailbreak? What are the steps that you can actually take? So you can actually throw a caution screen to the user. You can restrict few features. Maybe just give them read features. Don't give them functionality. Just prohibit that once you detect jailbreak. Also, you can actually log that session and report that user immediately. You can actually take other security actions pertaining to your SOPs that you have implemented in your platform or company. And also education, because we don't talk about this. We just talk about, okay, there's a security breach. We should just take some action. You should also talk about educating your users to not use jailbroken devices, rooted devices. Okay. You have seen this whenever you try to use a banking application. You on a rooted device, you will not be able to access that. So those applications actually forfeit you from using a rooted device. So if you're an enthusiast, you can actually just say goodbye to all the banking applications if your device is rooted or jailbroken. So education is quite important. And some people are doing it for just tinkering with the technology for learning and stuff like that. But some people actually have some criminal intentions for using jailbroken or rooted devices. So we have to actually also educate our users to look out for these sort of things, because a social engineer attack can actually happen, and someone can actually give you a rooted device, install an app, try to make you authenticate. Something like that can actually happen. So you have to make sure that these things don't happen. So education is important, and also continuous monitoring. When you're continuously monitoring jailbreak and all the behaviors that the users are doing, because when you're building application, you're not just building your application and you're sitting in dark. You're actually monitoring your application performance wise. You can also track events and everything, and every company does that. It is part of the job, right? So we implement uh, uh, different sort of analytics and everything on our application. So we should monitor those things as well, and make sure that we also improve our jailbreak detection system. Because there's one. Let me give you an example. So let's say you are using JailMonkey, and you're using a variable called isJailbroken. A hacker knows that he can just go to your code, reverse engineer, and see where is this jailbreak variable. He'll just put an exclamation before that, and everything will be open. Zero security. So you have to make sure that you hide these things in your code base. Okay. We'll also talk about how to hide these things in your code base. Let's move forward. So you guys must have come across this thing in your terminal very often while installing a npm package or something like that, right? So it says that 104 vulnerabilities, 93 moderate, 9 high, and 2 critical. How many of you guys actually take action on this? How many? Oh, nice. So not everyone, right? Not everyone is security focused. Not every team is security first. It is given, right? It depends on different teams as well. Some companies don't even want their developers to actually focus on security. They want to ship the code faster and everything. So yeah, not everyone thinks about this, but yeah, you should always think about this. If there are vulnerabilities in your code, at least make sure the critical and high ones are sorted. Don't use that dependency, or try to install something else. look out for alternatives. Okay, so we are building React Native applications. It is very common that we will rely on third-party applications, third-party libraries. So there will be some sort of vulnerability in there. So you have to assess these libraries. You have to make sure that you also go through the code once when you are installing something. They should be popular. They should be very well maintained and everything, so that you can actually mitigate these chances of security breaches. Uh, Also, you should actually implement a CI/CD pipeline where you're checking for these vulnerable dependencies on every PR or commit as well, which will actually enhance your security. I have also mentioned some tools that you can actually use for checking your dependencies: OASP dependency check, retire.js, npm audit, etc. Talking about testing process, I believe every company goes through a VAPT every quarter or every half yearly or something like that for compliance reasons. But let's keep the compliances and regulations aside and think about security as a critical thing. And we can actually enhance our security by, let's say, focusing on a simple process. You can actually check and assess your software for vulnerabilities. You can assess your libraries for vulnerabilities. You can do a penetration testing yourself, and you can then create a report. Make sure that you also take in consideration all the platforms and models, multiple devices and everything. Create a report and then try to create an execution plan so that you can actually mitigate these vulnerabilities in your application. Okay, it should not just be for the sake of compliance. Let's come to JavaScript obfuscation. So obfuscation is a technique that makes code harder to read. We are basically running a function. We'll send a very good-looking JavaScript code, and we'll get gibberish code out of that. So basically, it helps users or hackers or people with bad intentions to reverse engineer our app and get access to the logic. So it is very important for us to actually obfuscate JavaScript code. And these are few tools and technologies you can actually implement or use. JS Scrambler, JS Defender, these are two platforms that you can actually use to obfuscate your JavaScript. And these are two NPM packages in the last two ones: JavaScript Obfuscator and React Native Obfuscating Transformer. It's quite difficult to pronounce. So this is a very good looking JavaScript function. Okay? And let's see what happens after we obfuscate it. I have prettified it, by the way. So it was like total gibberish. So you can actually not understand what is happening. All the strings, everything will be converted to this weird looking syntax. Okay. And this actually helps. We can actually implement this in build time and also make sure, because there's an intricacy here, because when you obfuscate your JavaScript, you will actually lose your source map. Okay. So if you do it at build time, you can actually use a good tool which can actually output a proper source map which will correspond to the obfuscated code. And whenever there's an error, you can actually try and fix that easily. Otherwise, you can, if you just randomly use a simple obfuscator without a process where it is giving a proper source map, you can actually lose the source map, and then error finding will be difficult for you guys. Okay, so talking about storage, we have async storage in React Native, which is not very secure, and we have our native counterparts, Keychain and Keystore, secure Android Keystore, which you can actually use to save your auth tokens, save important customer data on client side if you may. But I would always suggest keep it in the backend, fetch it from the API. It's way better. But yeah, you have to store certain tokens and everything in front end, right? So I would highly suggest to use these libraries and platforms to save those. But also you have to understand, we are not encrypting. These are secure storages. These are wrappers for native storage solutions like Keychain and Android Secure Storage. Okay, so you have to make sure you can also add a level of security by adding an encryption step. So while you're saving these in client, you can actually encrypt that data and then send it to Keychain or Android Secure Storage. Let's talk about SAST. SAST is Static Application Security Testing. And basically what it means is you will test your code base. You will not run the app. You will test your code base for vulnerabilities, for security issues, uh, And you can easily implement this thing in your CI/CD pipeline because it is just scanning your code, right? And you can use these tools, Mend, SAST, Sneak, Fortify, Sonar Cube, to actually do that. At the same time, there are two more things, two more concepts: dynamic application security testing. So this sort of testing will happen when the app is running. So it is real time, and it scans your app for loopholes and security issues. And then we come to interactive application security testing, which is you're doing it SASC and DSC together. So you call it interactive application security testing. So it will actually enhance and maximize your overall security. Certificate and SSL or SSL pinning. So basically, everyone must have read about man in the middle attack, right? So it actually happen. It can happen through various ways. Someone can actually use DNS poisoning to do a man in the middle attack to your application. So what happens is whenever your a client and a server is trying to communicate, there's a SSL handshake that happens. There's a chain of HTTPS certificates that actually you sign. There's a self-signed certificate. There's a certificate which is in the middle signed by some third-party authority. One is signed by your server. It sends you. You check the public key, and everything happens. So, but the problem here is someone can actually come in the middle of that communication, put a different certificate, and make your client interact with a different server and try to intercept your data. So to prevent that, we can actually implement SSL pinning. So what we are going to do is, in very basic term, we will be pinning the fingerprint or an hash of previous certificate where the connection was secure and seamless. We will keep that in the front end. Whenever we do another handshake, whenever we do another connection, we will make sure we equate that hash or the fingerprint of that certificate with the certificate we are getting right now. If it matches, you're good to go. You can actually have a proper seamless communication. It is secure. If it doesn't, then there's someone who's trying to actually try to intercept things. So there's a man in the middle attack happening. This diagram can actually help you understand that better. So there's a handshake happening. And when you do SSL pinning, so client is actually having a sort of fingerprint. It is taking a fingerprint in state and it is checking it against the certificate that is coming from the server. So it can actually help you prevent man-in-the-middle attacks. Okay, so implementing. I had like 4-5 slides, proper implementation with code. So for the sake of time, I'll just explain how can we implement SSL pinning in our application. So there are several ways. You can actually go the JavaScript route. You can actually use a library and implement certificate pinning like that. You can use React Native SSL pinning, quite famous. React Native cert pinner. To implement SSL pinning, it's very easy. There is a native step. You have to go inside your iOS code. You have to go inside your Android code to actually, switch on few stuff. But yeah, it is pretty easy if you use a JavaScript library. There is a native way to implement it as well. In iOS side, you can actually use Trustkit. You can install it through CocoaPods. And in Android, the interesting part is React Native Android uses OK HTTP library for doing network calls. And this library supports SSL pinning out of the box. So it's like a matter of seconds that you can actually start, building your SSL pinning system in your application. It's just few lines of codes that you actually have to add, and you're good to go. So what do you understand by this? What is this? It's right there. So basically, this is deep linking. Okay. So whenever you try to open a link, let's say LinkedIn on your phone, it goes to the application. But how does it happen and why do it happen? Right. So we use deep linking, something called deep linking to do that, to achieve that. It is majorly for user experience, nothing else. But yeah, there you can also see, basically in this diagram, you can see someone clicks on a link. If the app is installed, you will be redirected to the app using a deep link, or you will be redirected to Play Store or App Store to install that app first and then open. Because very basic understanding of this is people who are building the application would want you to use the application as well. And if you're using the web only, or you're just opening that website on Chrome, you will just not use the application. It can happen, right? So they also want you to use the application because there are some native level features that companies can use to actually send you push notifications and everything that is not really possible in browser as of yet. So yeah, deep linking exists. Okay. So basically, opening a specific corresponding screen through a URL on your application. We should always make sure that we follow these three things to prevent phishing attacks and to ensure security while we are implementing deep linking in our React Native applications. Make sure that you validate the URL. Make sure that the URL that you're trying to open on your application actually is the URL that you want to, because it is your own company's URL, it is your own server. You have to make sure that proper access control is implemented, because let's say there is a private URL, you don't want other people or public to actually access that. I don't want my customer to actually be able to access some other customer's data, right? It can be a nightmare for security teams, right? So you have to make sure the access control part is properly implemented and you are not exposing your private URLs. URL pruning, basically, as the name suggests, you prune your URL, means you'll just cut the unnecessary part from the URL. You'll remove all the unnecessary things. Or sometimes what developers do is they send tokens and secure things that should be kept secure through URL parameters, which is not a good thing, right? Storing important tokens and sending it to your app via deep links, which is actually not right. So keep it in the backend, maybe fetch that data. Do not send it through URL parameters. So you have to make sure you prune your URLs before actually implementing deep links. Just make it look better. It's good for navigation as well. Okay. Now coming to platform specific concerns, we've talked about general concerns, React Native level concerns, but there are platform specific concerns as well. What if there's a vulnerability in Android, latest version of Android or previous version of Android that your users are using? You have to make sure you have to account for that as well. You have to account for things going wrong in iOS side of things also. It is not actually very secure as well. Okay, so you have to make sure you recognize the differences in those platforms, because you're building for React Native, you're writing one code base, but actually you're shipping two different applications. So you have to make sure there are intricacies that are going to happen in different platforms, to make sure that you actually look out for those things. Make sure that you actually have those things well planned. You make sure that it is part of your testing plan as well, both iOS and Android, checking if the app works fine, if it's secure. Okay. You also have to align permissions. So there are different permissions that you have to actually, native level permissions that you have to take for certain features and functionalities in your application. So these are two different things, because iOS implemented in a different way, Android implemented in a different way. So you have to make sure you account for those. Also opt for native storage like keychain and Android secure storage, as I mentioned earlier. And also respect the authentication standards, because again, these are two different implementations of two different operating systems. You're building one code base, but you have to make sure you respect the authentication method and security guidelines that these two operating systems actually give you as developers. So make sure that these platform specific concerns are also met, right? Okay. So coming to privacy regulations and compliance, everyone must have heard about GDPR, SOC 2, ISO certifications and everything, because these are few important things that you have to actually comply to actually sell your product. Okay. So sometimes these are actually enforced by countries, continents, and sometimes these are voluntary certificates. Let's say a GDPR. GDPR is like implemented and enforced by European countries. But SOC 2 is a voluntary certification that you can actually get for SaaS products specifically. It actually instills confidence of your users in your applications. So I'll give you an example. Long back, I was building an application, and to onboard few customers, we had to actually get SOC 2 certification, because that company wanted us to comply by SOC 2, because they have some certain security guidelines and security checks that they do when they're trying to buy software from outside, or SaaS products, or any company, or any software in general. So you have to always make sure your software is compliant and you adhere to these privacy regulations, because uh, there are penalties. Okay, so if you are not compliant, you will actually can get a heavy penalty on your company. So penalty is one motivation that you can actually use to comply and make sure these regulations are met. Also, trust and reputation. User trust and reputation is very important. If your user trust in your application, your business is good, you're making money, you're fine. Okay, so security plays a very important role. You guys must have heard about the political drama that happened with Facebook, right? After that, people stopped using Facebook. The trust also reduced, right? And now what is happening with Twitter? Things like these things happen, right? So you have to make sure user data and everything is really secure and well guarded. Then only your user will be, trusting you as a platform and will be, using your platform. And that's what you want, right? In the end of the day, it's business and you want it to flourish. Also, there are regional variations, as I told, because some certifications and compliances are enforced by some countries, like GDPR by European countries, and some are not. ISO certification is also important, which is Indian certification, like very Indian certification. Okay, so let's talk about how to secure our CI/CD pipelines also while we are building React Native applications. So for every PR before merging, you can actually have a SAST check. That's what we talked about earlier. We can check for vulnerable dependencies. We can ensure storage is like secure storage is used. Storage should not be used without encryption. We can also run automated tests to verify authenticated parts of our application that should be not accessible without authentication, right? For release builds, we have to make sure that all the prod SSL certificates are injected into the app at build time. We have to make sure that deep linking vulnerabilities are taken care of. Also, signing the application with a release certificate from pipeline to prevent from it being getting leaked. And also testing and hardening the release builds on jailbroken and rooted devices before releasing the application. So these are few things, key takeaways that I wanted to share with you guys. So final words. I hope you guys actually like the presentation. I captured your interest towards security and securing your application in the front end side of things. It is very important to have a security first approach as development teams because it can actually help us from very bad situations happening in our company and for applications. It also instills confidence, ensuring that user data is being like kept safe, and security as a foundational practice should be implemented to improve trust in the technology that we create and to build better and safer software. Okay. So I hope as you continue your journey as developers, I actually encourage you to carry this message forward and make it as a guiding principle in your work to make sure that you think security first, always. Okay. So a key takeaway. The only reason I gave this talk for this. So yeah, I hope you like the talk. Thank you so much. We can connect. You can actually scan this QR code or maybe go to my website. Everything is there. Okay. And I'll be releasing a blog article about this with proper code implementation as well. If you guys really want to read it, connect with me. You can actually see it on my blog. Thank you so much.